This is Laura Duncan from CSMS. Today we'll be representing polynomials with algebra tiles. First of all, an example of a polynomial, poly meaning many, is 4y squared plus y plus 7. That has three terms. A binomial, written above, is 2x plus 3. We'll be representing those terms using geometric figures or the area to name the tiles. So if we're finding the area of this square right here, it'd be a 1 times 1. So the area of that is 1. So that tile represents 1. The area of this one is 1 times x. So simplifying that would be x. This tile is representing x. However, in this one, it's x times x. In that case, it would be x squared. And guess what? It's a square. So hopefully when you see these, you'll be able to identify which term it's representing. We are simply finding the area to name the algebra tiles. So from henceforth, a 1 unit tile will be 1. The little rectangle will be x, and the big square is x squared. When we're looking at signs of tiles and we're drawing them, these are going to be the positive tiles. However, if we shade them in, these are going to represent negative numbers. For example, this would just be positive x squared. This one would be x, and this one would be a positive 1. However, on the negative side, we'd have negative x squared, negative x, and negative 1. So now let's try our hand at modeling polynomials. This term right here is 2x squared plus 4. So the coefficient here represents how many of the tile is represented. So the tile is x squared. So it's x squared. That's the big square. And there's 2 of them. That's the coefficient. And then it says plus 4. When we're talking about the numbers, we're going to represent the number 4 by 4 of the small unit tiles. So this is 2x squared plus 4 represented. Let's go on to the next one. Again, the coefficient 4 tells you how many of the term there is. So this one is x squared, and there are 4 of them. And they should look like squares. The next one is 6 times x. Well, that means there are going to be 6 of the x's. And lastly, it says negative 2. So that's the unit tiles. So I have 2 unit tiles. They're small squares, but they're negative. So please shade those unit tiles in. Now let's look at another problem. What I want you to see is in front of the x squared, the coefficient is 1. There's an understood 1 there. So that means we're going to have 1 x squared, and it should look like a squared. Next, the coefficient on the next term is 3. So we will have 3 x's. So 1, 2, 3 x's. 3 times x. And then lastly, we have the term negative 5. So we're going to have 5 unit squares. However, it's a negative 5. So to represent negative 5, we will shade in all of the squares. Now let's look at number 4. The coefficient on x squared is negative 2. That means we're going to have 2 x squareds. Now because it's negative, it's going to be shaded in. So this will represent negative 2 x squared. The next term is positive 2x. The coefficient is 2, so we'll have 2 x's. Because it's positive, they will not be shaded in. And the last term is negative 1. This could also be called a trinomial because there are 3 terms. Remember to shade in that negative 1. Now when we're given polynomials, we're going to write them in algebraic terms. So let's look at each one of these. This is an x squared, and it's a positive x squared. And because there's 3 of them, we could represent it as 3 times x squared. The next term is negative. These are x's. And because it's negative, it will be represented by negative 2x because there are 2 of them. And lastly, the units. We have 1, 2, 3 units. So this polynomial would be represented by 3x squared minus 2x plus 3. Try the second one on your own. Pause the video here. In this binomial, because there's 2 terms, we don't have any x squareds. We simply have x's, and there are 2 of them. And then we have 2 units that are negative. So this binomial will be represented by 2x minus 2. In the third example, all the terms are negative. So keep that in mind as you're doing this problem. So first of all, we have a negative x squared because it's shaded in. We have 1, 2, 3, 4 negative x's. And then lastly, we'll have minus 3 units. That concludes your lesson.